Hey folks, Blake here, and welcome to another episode of our Unity base building game series, codenamed Project Porcupine. Last episode we did sort of an introduction a little bit to the Lua interpreter, plus we discovered certain problems with trying to read in the Lua file in Unity because .lua extension files aren't one of the files that Unity recognizes as a text file. Therefore, it doesn't get bundled in the resources properly, which means we can't use the resources.load text asset. Now, one of the things, I didn't actually address this, one of the possible solutions is we could have just had our Lua file end in .txt. That would have been perfectly fine. Then Unity would have been like, yeah, this is just a text file. I will happily load this in. And we could have then fed that text file into our Lua interpreter. But I want to use the .lua extension because, you know, that sort of tells you what the file is. Plus, if you open it in an appropriate text editor that recognizes Lua files, it'll give you all kinds of pretty syntax coloring. So I want to do it the right way, which is to have a .lua. And unfortunately, that means we can't use resources.load assets because it doesn't recognize that as one of the possible text formats. Now, XML is, which is why our data/furniture.xml file here worked just fine in resources. But as I said at the time, I didn't want that XML file to live in resources in the long run because the resources, while it does get bundled with your program, it isn't a special like Unity asset. What's the extension? I think it's .unity asset, or maybe it's .asset. But the Unity asset bundle format, which isn't something that's easily editable by other people. So I always said we're going to have these files sort of live on their own on the file system. That's exactly what happens with the streaming assets folder. This is a special magic folder name. And when we build our program, when we go build settings and hit build, this exists as a normal file system folder, and with the files inside just perfectly normal and perfectly accessible. The downside is Unity then at that point doesn't have any sort of automatic or simplified way to load in this data. We have to use normal sort of C# file loading and file reading kind of code. Now, because I moved our furniture.xml file outside of resources, currently the program doesn't work because right here it borks, because I still have this old line of trying to load our furniture XML data from the resources loader, but it's of course not sitting in the resources file, so this doesn't work anymore. In fact, it can't load as a text asset at all. So instead, what we need is something like this. So we need to, see, in the future, instead of using the Unity resource system, we'll be reading it from a regular file on the hard drive. Awesome. Well, let's do this. We still need sort of a to-do. Probably we should be getting past a stream IO handle or the raw text here rather than opening the file ourselves. Okay, because again, this is our world.cs file, and I really don't want it to be aware of the outside world of the system it's living in, so probably it should get past something, but for now, let's go ahead and do that. So, we're going to have some sort of string, which is, I guess, our furniture XML data? I mean, this is sort of the raw text. Furniture XML text maybe is actually a good idea. So some sort of string, and that's the string we're going to pass over here. There we go. So that way our reader will be able to parse some text coming in. But obviously, we have to get the text out of our file and into this string. There's luckily a pretty easy way to do that in C#, and that's to use, so system.io. This is the library that handles all sorts of input and output I/O, and specifically, the .file one is responsible for inputs and outputs to and from files, and it has a really handy function called read all text. You give it some sort of path to a file, okay? Some sort of, file/foo/bar.text or whatever, okay? You give it some sort of file path, and what it does is it returns a string. So we can just actually do that. I mean, we don't even have to keep it in here, but that way we get to push it over here, and we could do something like debug.log, do this, and we can confirm that it's working okay, for example. Great stuff. Now, the question is, what is the correct path to our file? I mean, we know that in the end, it's going to be furniture.xml. Okay, and actually we know that it's inside of, say, data/furniture.xml. But where exactly on the file system will it get stored? And well, this varies depending on what operating system you're on. And of course, where people have their game installed. It can be in completely different places. It'll always be like sort of next to the executable, but it'll be in different places. And the way that you put together these paths can vary by operating system as well. This is not like the clean way of doing it. So instead, what we're going to do is we're going to have something like string file path, okay? And we're going to start with something that is built into Unity. We can ask Unity, hey, where's the streaming assets folder? Where the hell is it? So if we do this, and then we go debug.log file path, and then let's say we just return right away so that we don't process anything else. Let's see what happens when we run this. I will hit play, and we will stop. There we go. So currently, our streaming assets folder is H Sites Project Porcupine episode 59. Wow, 59 episodes, geez. /assets /streaming assets. That's great. And I mean, if we built this, then it would be sitting in a slightly different folder with a slightly different structure. Excellent. Okay, so we're part of the way there. Now, we know it's going to go further down here. It's going to go into data furniture. But again, what you want to avoid doing is something, say, like this. Does it have a slash at the end? No, it doesn't. So we'd want to put in something like data/furniture.xml. The problem is, again, you can't really know for sure that this is the correct way of building your file path for all computers. So it's actually much safer to do something like this. You will run something like, say, system.io, but instead of going file, we go path, combine. So this function knows the correct way to combine parts of a path. So I will put in, at this point, say data, just data by itself, because I think, yeah, you can only put in 2 strings. And then I'm going to do this again to add in our current file path, and then add furniture.xml. I mean, maybe I could just go /furniture.xml here, but again, I'm going to leave it up to this helper library to use the correct splitter in paths. If this were like old school Mac OS, for example, the correct way to divide the paths would be, I think it's like ::. So like instead of a slash. And then, you know, this would also potentially handle / versus /. Not that that's much of an issue anymore. So I think if we do it this way, this is like maximum safety. It's probably an extra level of paranoia, but better safe than sorry. So there we go. So now if we hit play, actually even that, it puts the slashes together in a slightly funky way. It's using backslashes here and / there. Well, the / is from Unity streaming asset path. Now I believe that it's going to be okay using both here, hopefully. Well, I guess we're going to find out in a second, because what we're going to do is we're going to remove this return. We'll still spit out the file path, but we're going to tell the file system to read all the text from that particular file, and then we're going to output it and see if that works. So we're going to hit play. And it works. Look at that. Our XML file is there. Excellent. So it loaded things in from this path and spits it out, and then correctly 5 furniture prototypes can get read, and the buttons work. So we are now, instead of reading the XML file from anything related to Unity, we are now reading it directly off the hard drive as a normal file. That's great. So let's clean this up. Let's go read these debugs over here. Excellent. And I mean, we could put this in some sort of helper function, but it's only like 3 lines to get it to work. So I think that's going to be okay. So what I'm going to do is copy the same thing. And now in our create furniture prototypes. Oh yeah. I was going to say, we're loading the Lua in setup world right now. We've got to comment it out. But let's take this. And actually, I think it makes perfect sense that we should, when we create the furniture prototypes and read in our XML, that's also the same place we should read the Lua. Now, I think the Lua will have to exist first, because when we read in the furniture, remember, what we have here is in the XML file, for example, for a little oxygen generator, we say, hey, on update, run this function name. Well, we should probably have the function name, the function already exist, because that way when we read the XML file, we can then use that reference immediately and link everything up. So the function should exist before we read in the furniture data. Okay, that's fine. So over here in our world where we create furniture prototypes, let's make another function here. Load furniture Lua. Let's do this. In C#, the XML is like that too, right? X, small m, small l. So we'll do the same thing. And so what we'll do is we'll load furniture Lua before we create the furniture prototypes. And what we're going to do in here is this. So this does not work. This is what we developed last time. And we tried to do resources.load text asset, the Lua furniture. It was a no-go because it turns out the files with the .lua extension don't load. We could have had a .txt, but I like having the .lua because it'll work better in text editors and whatnot. And it's the more right way to do things, so that'll be better. So then what we're going to do is we're going to just copy this bit over here. So what we need to do is instead of reading the file that way, we're going to read the file this way. And boom. And it's not data, it's the LUA folder, and it's furniture.lua. We're going to read all of it and stuff it in a variable called myLuaCode. We'll go ahead and output it to the debug log just to make sure, but then we'll call furniture actions and get it to parse that Lua code, and it'll actually execute it. All right, let's go ahead and hit play and see what happens. Dun, 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 dun. Aha! It works. myLuaCode, the Lua code is this over here. That's what we wrote, right? We can confirm that. If I open this up, there's my Lua code. You can see foo equals 99, function test, return n times 2, and end. And that's exactly our text over here. So we've confirmed it's read in correctly. Then we are executing that script. The null is what the script returns, and we don't actually have a return function in the script itself. Like if we did, we could do that, right? I could have a return script. Or how about Lua script parsed, like that. So now if I hit play, bum, 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 Lua script parsed. So this script, which again, we can see the script in here, right, including the last line, it runs, and what that does is return Lua script parsed. But as part of running this script, we are also creating a variable called foo and setting it to 99, and creating a function called test, which does this. The next thing we do is we actually run the test function. If we look over here, right, we load in the script, we get the result, we output that. That's the Lua script parsed. Then we call a function called test. We pass it a value of 111. And if you look at our script, our test function takes the value that it's passed, multiplies it by 2, and returns that. So that should be 222. And that's exactly what happens. We get that. Awesome. So we are now successfully reading and executing a Lua script, which involves defining a bunch of functions. So now the next step will be to tie that together with our furniture.xml file, right? So we've got this on update gas generator. So what we really want is some sort of script, some sort of function in here. Function on update gas generator that does something, and it should get past stuff. In fact, we know what these furniture updates get passed. They get passed the furniture and a delta time to say how much time has passed since the last time this was run. So the same thing will happen in our Lua code. We'll get passed a reference to the furniture, and we'll get passed a delta time. Now, we don't have to define the type here. We don't have to say that it's an integer or a float or anything like that. Because the Lua does dynamic typing, so we just have to provide some sort of name, and then it just has to do a thing. It doesn't have to return anything. By default, it would count as being, returning null or whatever. But we want to do a thing with this. Yeah, okay. So, right now it's not going to do anything, but we want to call this. And we want to have this called sort of intelligently and automatically. So how are we going to do that? Well, clearly we're going to have to make a couple of changes to our furniture. Because right now, we don't have furniture open. Right now, if we look at our scripts and our model for furniture, we have our, what's it called? Update actions. And this wants to point at an actual C# function, right? An action is a C# function that takes two parameters in this case. It takes a furniture and a float. And so we get a list of these. But we don't have a C# function to point to anymore. Instead, this is going to have to be basically a string. Well, that's not entirely true, because we could, what am I looking for here? Oh, in furniture actions. Right? There's two ways for us to keep track of the function. Either we can keep track of the label, or we can keep a reference to the function itself, which is basically like this is, it's a dynamic value, some function, which is equal to that, and then we're going to call some function. So in our furniture, we could have a list of these sum functions, or we could have a list of strings. I think it technically would be a little faster if we kept this around, but I don't know if I want to have like these din values everywhere. I think I would quite like just a list of strings to run. And the extra level of indirection of looking up in the globals is pretty minimalist. So we're going to go ahead and do that. So our update actions, we're going to change this. I mean, this is going to be a little bit painful, but not too bad. Instead, we're going to have a protected list of strings called update actions. And then we're going to have to find all references to this. All right, if update actions is not equal to null, then what we do is we're going to do what? We're going to call, well, I guess we're going to call furniture actions. So furniture actions should actually have some sort of function here that says it should be a public. I guess a void is probably fine. Call functions with furniture or something like that, which is going to take in a list of strings. Actually, I guess it really just needs an array of strings, which will be auto-converted. That's okay. So this is going to be the function names, and then it's also going to want a reference to a furniture. And this is going to be responsible for calling those scripts, those functions over and over. We're going to have to populate this in a moment, but let's assume over here what we're going to say is we're going to say furniture actions. Well, actually, it's not a static anymore. We need an instance of furniture actions. I guess it could still be a static class. Because static classes can still have constructors. Like that. Oh, right. It needs to be parameterless. So you can have a constructor that does this. And this would be fine. But not very helpful. So, well, I guess we can do sort of like singleton style. So static instance of furniture actions. Like this. And we just set instance to be equal to this. And then we make this a static public void. Which means we can now call this like so. So we give it the update actions, and we tell it to run on this piece of furniture over here. So this will call all these functions one at a time. So we can do something like for each string function name in function names. And then, well, we've got to call it on the script. So our furniture needs to have its script be an instance thing. So we're going to clean this up. We're going to remove all these tests and things like that. We don't need the results anymore. What we're going to do is we're going to read in this code. Oops. We're going to, I guess I don't have to define it. It'll be protected by default. We're going to take in a string. We're going to instantiate my Lua script object. we're going to process this string into Lua code. We're not going to do anything with it. We don't store the result or anything like that. We basically are compiling it once. And then the MyLua script will then have... let me think here. We'll then have created everything. Yeah, inside of its globals. So it'll still have that global reference to, well, whatever we created. It'll still have the test function, but it'll also have this onUpdate gas generator as part of the script. That's all been processed in. This return where we say Lua script parse, we just ignore it. We can remove it, we can do whatever. Let's just leave it in there and ignore it for now. So for each string in these function names, what we're going to say is my Lua script, instance.myLuaScript dot call. And then we're going to say instance.myLuaScript.globals. So we're going to look for the function name in the list of globals. And we're going to pass it furniture, because that's what it's going to want. So we're going to pass it some object. In this case, it's going to be furniture. Can we pass it just like that? I think we can. No, that won't quite work. But let's keep going for now. So for each function, we just make sure to call the function of that name over there. We might want to check to make sure it exists, right? Let's say we say dyn value func is equal to this. We say something like if func.type not equals datatype.function, then we can do something like debug.log error. Do something like, I don't know, that'll look weird. That way it'll come out in quotes. Is not a Lua function. Return. Right? So we're going to look up a global with the name equal to this function name, and if it's either this could be a null or whatever, but if it's not a function is the thing we're checking for. If it's not a function, then we have to throw up an error because clearly that's no good. Something went horribly, horribly wrong. And then what we're going to do is just call func, passing it fern. Okay, I think this will compile. I don't think it'll actually run. Oh, yeah, it's not a static class anymore. Get rid of that. Right, and we still have to clean up furniture because we have changed furniture from a set of actions to a list. Which, yeah, we definitely need to copy. Now, we don't have to... we make a new list. New list of strings, and we pass it the other.update actions. And there we go. So then we get a brand new list that points to the same things. Okay, we'll have to find out more errors with update actions because there's going to be some more. I think I have to say to array here to satisfy that. Okay, and then when we register an update action, right now it's not happy with that. So what we have to do is we have to say update action. So these are going to be strings instead, right? String Lua function name is what this is going to be. So we're going to go update actions dot add Lua function name. And same thing over here. We're going to say remove. Now, we don't actually instantiate update actions right now, so we're going to have to do that in our constructors. Boom equals new. And our copy constructor already does it with the new, and then we need one more over here. Although, we don't actually do this from parameters anymore, do we? So I can just comment this out. I don't think we use this version with the parameters. Then cannot implicitly convert object to dyn value. Was this not a... Does this not require a dynamic value? Or does it seriously just return a function, an object? This is returning an object, which this accepts, but it must be a dynamic value. I don't know. Let's try casting it and see what happens. I might be wrong about that. Variable phase assigned a value but never used. Right. Instantiate the singleton. We can almost certainly clean this up substantially because this is kind of weird right now. We also have no way of confirming that our code is actually running. So I'm going to have this return. Oops. Return foo. When this runs, we're going to return foo. Oh, and it's got two parameters. That's right. It needs a it wants a delta time. Can I pass more than one parameter in here? An array as args. So new dyne value array with fern as 1 and delta time as the other, which we don't currently pass. There we go. So pass an array of values in here. And most likely that means where we're calling this from. We have to pass it the delta time. Nope. Delta time. Cannot convert type furniture to dyne value. Right. Would this take an array of objects instead? It does take an array of objects. That's what we want to do, because then it'll auto-convert to the right thing. Okay, we're getting there. Then we want to get a result here. So we get dyne value as a result, and then we're going to output it. Debug.log. I'll just output result.string so we can see if it's working or not. So assuming we've done this right, then we don't actually set. We don't actually register the thingy. When our furniture read XML prototypes, we get the line for on update. We get the function name, right? We're going to get on update function name. We're going to get some piece of string in here, which is what we're getting. Then we're going to register update function. We're not going to say string to function. We're just going to give it the function name because this just wants a string now. So if we've done it right, when we load the program, it'll parse the Lua, then it'll parse the XML file. In the XML file, it'll catch a reference that our oxygen generator has a certain on update function. That will get registered, just a string name. It'll just be a string added to an array. And then on every update, we will tell the Lua parser, the furniture actions, which is our Lua parser, that it has to run a function called, I don't know, oxygen generator update or whatever it is. And that should, on update gas generator, should just return foo. Let's make sure we've got this text correct. It's the old one from the previous project. That's funny. In our XML, we've got that matched. Yep, we do. Okay. This is just going to return a string value called foo, which we are currently debugging. So our log should get filled with foo every frame, unless we've missed something. Oh, I was going to say, why isn't it working? Because we don't actually have an oxygen generator put down. So load, put an oxygen generator right here. Oh, all right. So we are getting an issue. Cannot cast from source type to destination type. So it must just be an object that this is returning. So it can't cast it to dyne value, which is a little weird. So I guess we just check that func is not equal to null. Which doesn't necessarily check to see if it's a function or not. It just makes sure that it's not. Yeah, I'll have to see. There's got to be a better way to check that. Load, oxygen generator. saying on update gas generator is not a function. So it's not finding on update gas generator in our Lua, in our globals, which doesn't sound quite right. Doesn't sound quite right at all. Because it feels like... Oh. I'm an idiot. The function is equal to null, not if it's not equal to null. So it's working. It was finding it. I just had the check inverted. So I was thinking it wasn't finding it, but it was. Okay, let's try again. Hit play. Load. Build oxygen generator. Okay. So what is this error here? This is saying cannot convert CLR type furniture. So the reason is we are trying to call this function and we're passing it furniture. Like we're passing an instance of furniture over here. And our Lua script is saying, I don't know how to convert the furniture object to something that can be used in Lua. And that's okay. That's because we didn't put in a little hint. That is very easy to do. So furniture is a class in C Sharp over here. We want to tell it that you can access this in Lua, and we can do that very simply by saying, well, we do need to include this line, the Moon Sharp interpreter line. And we can say, hey, listen, this is Moon Sharp user data. This is something you can access in Moon Sharp. And now if we try to run it, I believe it will work. So again, load, again, drop an oxygen generator over here. Cannot convert. Oh, right. Derp, derp. So we put in this hint that this is valid, but we need one more step. Before we parse this script, well, actually, I don't think it matters where, but we have to put in a line. Tell the Lua interpreter system to load all the classes that we have marked as Moon Sharp user data. And we do that by saying user data, user data, this one here, dot register assembly. So this will process all of our classes that were flagged as that and get it prepped to get called. Let's try this again. Okay, just load, build oxygen generator. Hey, it's saying foo. That's amazing. Okay, it's saying foo every single frame. Let's again revisit what's going on here. In our XML file, we say we have this extra line. On update, function name this. When we are parsing this XML file for our prototypes over here, we are checking these tags. We run into a tag called onUpdate. We grab that function name and we call register update function, which just adds that function name, which is just a string, to a list of strings. And every single frame over here, we make sure, first of all, the list not null, which it should never be. And then we say to furniture actions, hey, call the functions with these names. This is just takes in a list of strings and a piece of furniture and a delta time, loops through each one of those function names and calls each one of those function names with that piece of furniture, and currently is debugging the result. The function that is being called over and over is onUpdateGenerator, which simply returns a string called foo, which we then output over here. So this Lua code, it's not doing much yet. Well, it's really not doing anything yet. But this Lua code is successfully running every single frame in our C# program. So now we can start interacting with furniture and doing things. In fact, we will basically be doing exactly what we were already doing with the oxygen generator, which is somewhere in here. Oxygen, over here. We're going to be doing this, but in Lua instead, which is basically mostly just running like two little lines over here. But you can see it's going to require a few more things. Our furniture needs access to tiles, which is access to rooms, because we're changing the amount of gas in a room, which means this little tag that we said, hey, this thing is accessible in Lua, we have to do the same thing for tile and for room. We may have to do it for other things as well. In fact, we will for jobs and whatnot. We're going to say, hey, yeah, this thing you can access in Lua, and this thing as well you can access in Lua, which does require us to add in the Moonsharp interpreter library at the top. Otherwise, it's not going to be happy. This will now compile. So then we can make references to tiles and rooms in all this data. And by default, this gives you access to things that are public, right? So we should be able to, in our code, because furniture's got a tile which is public, or at least the getter is, so that should be fine. We should be able to access this in our Lua as well. We should be able to do things like furniture.tile.room, and what's the rest of the code actually? Right, make sure it's not null. I don't know how to check for null in Lua. We'll have to take a look at that, right? But basically, what we're going to be doing, in fact, I'm going to copy this. What I'm going to do is paste it over here. Now, this is C code, or C# code, so obviously we're not running this. So we're going to comment all this out. Those are Lua comments. So then we keep a reference to it. And what we're going to do is we're going to rewrite this in Lua form. But that will have to wait until next time. Thank you very much for watching, folks. I'll see you then. Thank you everyone who pledged on Patreon to support these videos back in May, and are therefore keeping this series going from June through to early July. And a special thank to these Mike Check level supporters. We got Speedy Savant, Valiant Cake Fiend, Aaron Toibson, Marius Field Vold, Jan Torrevel, Julien Auger Lafont, Steven Stager, Michael McClintock, Kale the Quick, Drazion, Adjective, Jason Yanity, Wes Oldenboving, Craig Mortel, Neil Blakely, Milner, and absolutely everyone who watched, shared, favorited, and subscribed these videos. Thank you very much for keeping this series going, and I'll see you next time.